I get some Oracle certifications, and today's topic we are going to talk about is Oracle Database 12c Release 1 was great, and 12c Release 2 is awesome. Obviously, you know that now we have 18c, which is available in cloud, which has got some better and new features. But for today, our scope is until 12c Release 2. And a quick slide about Oracle ACE programs. Since I'm a member of Oracle ACE program, this is very nice program to be part of if you are into industry, and if you're contributing, if you're sharing stuff, then you should go and give a try to this. And there is a URL in the bottom of the screen. You can find more information about the program. So this is about the data intensity, which is my workplace. We get a large enterprise at this point, 1,000+ people, and we have verticals of database, applications, and BI analytics, and we got various delivery models. If you see on the left side of the screen, so we have the professional services, we have managed services, we have our own cloud offerings. And in middle of the screen, you should be able to see like what are we support within the database applications of BI analytics. And this is our delivery capability. So you can see like we are spread across the globe. And that's how we support our customers on 24/7 basis. With that said, I'll start with our topic for today. And if you know, like 12c Release 1 was introduced with more than 500 new features, and it was really great. When 12c Release 2 came, it came with even more new features, and that made it awesome because there were some features which got enhancement and became sort of complete. The good news is we are not going to talk about all of them. So we will talk very limited features which I found were really interesting, and as a DBA you must know them. So with that being said, this is the agenda. What I'll do is I'll quickly give a quick glance of 12c Release 1 and Release 2 new features. Then I will take a next step and I'll dig down a little bit in detail the multi-tenant features. And there will be a distinction between Release 1, Release 2, so that you know how it evolved. Then I'll take another shot and I'll talk about in-memory new features, and I'll make sure that it is distinct how it grew from Release 1 to Release 2. And at the end, we will do some question and answer if you have any questions. So with that, I'll start with at a glance 12c Release 1, Release 2 new features. So Release 1 came with a pluggable database. That was the key feature, kind of a game changer or in other words, it was a big leap. It was a brand new feature. It was a big leap in terms of like it was one of the major changes in the database architecture itself. Um, then there was a redaction policy introduced in Release 1. There was a very neat feature came like you can restore a table by armand, so you do not have to restore the whole database if you need to restore a table. There were some features came in adaptive query optimization and online stats gathering. You were allowed to move your partitions, sub-partitions online. You were able to do a multiple index on a single column. The only clauses like you can have one index online at a time, but you can have multiple indexes, but only one will be online at a time. There was something introduced in database archiving. So if you have to delete something, you do not have to delete right away. You can set it as mark for delete, and it will not be visible to your users. But and if there is no complaint, there is no requirement arise in some time, then you can go and delete it permanently. Then there were some data type increases, size limit, temporary undo was a big feature. After that, between 12c release 1 and 12c release 2, there was another major enhancement came was IM patch. First patch set was released and which gave uh, in-memory option as a new feature. So in-memory column store was introduced after the first patch. In the first patch, we had some more enhancements. One of them was advanced index compression. There was a performance-related feature came approximate count distinct, where if you really do not need exact information, if your approximation is fine, uh, you can use it and you can get real fast results. There was an option for automatic big table caching. I'm not going to read through exact syntax level stuff, but um, you have to set like a parallel degree policy, and there was a initialization parameter big table caching percent target. If you set those, then you should be able to do a big table caching. Then there was a another feature where you can do a full database caching also. And brand new thing was a JSON support that was big. So 12c release 1 has concept of PDB pluggable databases or container database, but there was no way to join two containers data and make a high level query. So then with the first patch that they introduced a containers clause. So you should be able to query data from two pluggable databases and join them with a containers clause. Then prior to this first patch said if you had to clone a pluggable database, then you have to clone it at its entirety. But with this, you were able to do a subset cloning. The way you say in the traditional LLMG world, if you had to uh, restore a database, restore a table, then you go and pick and choose like system table space and one or two table spaces which you need to restore. The same way you can do a cloning part. You can cloning of a subset of a pluggable database. There was a new feature came rapid home provisioning. This was for the deployment, and uh, there, there was a concept came called zip installer. So you do not have to install the software. You just extract it to a directory and run some configuration steps. Then there was a concept of partitioned external tables and many more. So and then 12c released two key features. Release one offered cloning, but you had to take your pluggable database in read-only mode. So 12c release 2 offered hot cloning. 12c release 2 offered PDB refreshes, or in other words called refreshable pluggable databases. Then there was a new concept called PDB relocate with zero downtime. I'll call it uh, near zero downtime. Then application containers. Then there were some in-memory enhancements. There was support on Exadata in-memory. So there was, I will call it Exadata in-memory enhancement because the in-memory support went to the Flash level. And one more big feature was like in-memory column store could run on an active Datagaurd standby side. That was a big enhancement. There was a new concept sharding with horizontal scaling. Table and column names can be set up to 128 characters long. And AWR reports are now available on active Datagaurd databases. There was a SQL plus history command introduced. So this was 12c release 1 release 2 features at a glance. Uh, I'll be I'll be taking it to the next level, and I'll talk a little bit more detail on multi-tenant features. So this was the first slide, which was introduced by Oracle to explain pluggable databases. I find it interesting because this slide, one slide talks a lot about the multi-tenant architecture, why it was there. So it says like self-contained PD for each application. So as Oracle promised that you do not need to change your application, and you can use this architecture, and clones were really easy to do, and so rapid provisioning, and you can unplug and plug, so portability was very good. um, Shared memory and background processes, so you can run more application per server, and since there are multiple pluggable databases inside a container, you can manage them all by one command, or with a common command. So you can manage many as one, and if you require, you can control them individually also. So there was a granular control. So these were the key features why multi-tenant was introduced, or when multi-tenant was introduced, these were the key features to introduce to people or users. So if you talk about, if I have to explain the architecture, so it's a database. It's architecture of databases inside database, and the outer database is called container, and the inner databases are called pluggable databases. It has a PDBC, which is kind of a template with which you can quickly create pluggable databases, and later on you are allowed to modify the seed so that you can have your custom templates. I talked about this. Okay, so this is another view of the architecture. You have control files, redo logs, undo, temp, system, and sysops as a shared files. But on the right hand side, you have your pluggable database, PDB1, PDB2, PDB3. They'll have their own system, sysops, and their individual table spaces and temporary table space. How you create, all you need to do is click this create container database, and then give your container database, pluggable database name. This is a DBCA screen. Then you can, if you have to manage them, then there is a manage pluggable database option introduced in DBCA, and there is create a pluggable database option also in DBCA. So these are the ways you can create. These are the one of the ways you can do pluggable database work. With that being said, I'll introduce with the first option, which was like for the cloning. You have one pluggable database and you have to clone it with another. Um, in this screen, I'm trying to tell you if you have two container databases, CDB1 and CDB2. CDB1 has a pluggable database Anuj running, and then you want to clone it as Mohan in CDB2. So what you'll do is you'll connect to CDB1 and place your pluggable database Anuj in read-only mode. Then you connect to CDB2 assist and run the clone command. But the key thing to notice here is that it will be in read-only mode. That was 12c release 1. Then with the release 2, hot clones were introduced, and if you notice that I do not have to take it in read-only mode, so PDB the source PDB will remain in read-write mode, and I'll just connect to the CDB2 and run the same clone command as I ran in the first previous screen, and it will be available to the users, but you should be able to clone it, right? So that was 12c release 2 multi-tenant enhancement. And these are the commands, and you should be able to actually use these commands and run it. Just have to do a minor modifications for your directory structure. Then, as I said, in 12c release 1, the undo was shared, but 12c release 2 gave a new feature called local undo. So the undo table space will come to individual pluggable databases also. It was an easy thing to change. Just start your pluggable database and start your container in upgrade mode and alter the database local undo on, and then do a shutdown immediate, and it will, if you notice with this, it will give undo to all pluggable databases, their individual undo table space. So why it was used? Because there were two brand new features came, flashback on a PDB label and PDB relocate, and those two features actually needed this to be enabled. I'll be talking more about them in the following slide. So this was 12.2 feature. So flashback on a PDB label, 12.2 feature. All you need to check is if local undo is enabled, one thing, and flashback is on or not. If flashback is on, local undo is enabled, then it's just quick commands like alter pluggable database PDB1 close it. Then flashback pluggable database to a timestamp what you want, and then just open the pluggable database with reset log option. So it's a like true flashback. You don't need to set up a auxiliary location. You just need local undo enabled. So then another set of feature came was a refreshable clones, and I'll quickly introduce you what it was. You There were two modes to create these. This was a 12.2 feature, so you can create a manually refreshable clones, or you can create an automatically refreshable clones. You have two containers, CDB1 and CDB2. You are creating a clone from CDB1 to CDB2. You have two options, manual or automatic. So if you're creating a manual refreshable clone, then all you need to do is create pluggable database CDB1, refresh mode manual. And within the dots, you need to fill the source from where you're creating this clone. Then once it is done, then you set this as your current container, alter session set container PDB1, and then you do open in read-only mode. The limitation was these refreshable clones can be opened in read-only mode. You cannot open them in read-write. So you can use them for reporting purpose, or there are many other uh, uh, many other use cases you can use them for. And then when you have to refresh it, you say like alter pluggable database PDB1 refresh, and it will refresh. On other hand, if you create a refreshable one, you'll use the same set of commands. The keyword you'll use is refresh mode every 5 minutes, every 1 minute, or any increment of minutes. And with that increment, it will refresh automatically for you. Very neat feature, and it was introduced in 12.2. So we talked about refreshable clones. We talked about hot clones. And if you just imagine that if you can clone something hot, if you can clone a pluggable database hot, and on top of that, if you can refresh it automatically, uh, you add both features, and then that will be equivalent to PDB relocate. So what PDB relocate was, your PDB here in this screen will be available to users, and you should be able to relocate. So all you need to do is create a database link between CDB1 and CDB2 and run a PDB relocate command for CDB1 and CDB2. 12.2 feature, and these are the commands. So you create a database link, and in the second command you just create pluggable database PDB2. So you're connected to um, CDB2 and say create pluggable database PDB2. from PDB to add database link CDB1 and do a relocate. And this is how it will work. It will be relocated to CDB2. Then there were some further controls you got, like if you're running a multiple pluggable databases, then you should be able to control like database cache size as your target, as your main size on a PDB level. And then you can set a PGA aggregate limit also on a PDB level. And PGA aggregate target too. They all were introduced in 12.2. And then you are allowed to control even IO operations also. So max IOPS and max MBPS were two parameters which you could set, and you can control the IO also. So this is not Exadata until 12.2. This was only available in Exadata, but now it was available to any 12.2 database which is using multi-tenant architecture. And if you set these parameters on a PDB level, scope will be at PDB level. And you can set it on a CD level, scope will be all PDBs in the container. And another key thing to remember, if you set it on a CDB level and PDB level, the precedence will take what you set. what you set on a PDB level than the CDB root. On a security side, they introduced a lockdown profile. What this feature was, you create a lockdown profile, you need to have a create lockdown profile system privilege, and uh, probably the last three lines will explain you a little bit more what it was. So I created a lockdown profile, I assigned it to a user, and within that profile, what it had is like, I created like HR underscore prof as my lockdown profile. And then I said like alter lockdown profile, HR prof, enable statement, alter system with a clause plus shared pool. Then the next statement I said like disable alter system. So what remained was alter system plus shared pool, but any other alter system capabilities were gone because I disabled them. And with that, if I give this profile to a user, he should be able to flush the shared pool but not run any other alter system command. And if you want to do more reading, I have some links here you can use. Then 12.2, a new feature, application containers, and I'll in the following slides I'll tell more about it. But one of the goal of the multi-tenant architecture was to give you one-to-one relationship with the application and database. They don't want to use like schema level consolidation because uh, people may not have a confidence that their data is properly segregated. So, but within the pluggable architecture, it's segregated well. So, but if you're running a small SaaS kind of applications, there was a limit, or there was a challenge how you update your application if you're running into like 500 locations. So this architecture will help you doing achieving that, and I'll explain you how. So architecture-wise, it's a regular pluggable database multi-tenant architecture, except the new thing which was added was here, this part. Now you can have a application PDB root. So you can create a pluggable database as an application container, and I'll show you how. there was a clause when you create a pluggable database use as application container, then begin and end install clause you can use for installing application, and how you synchronize with the clause sync. Then the individual commands. In the first box, I'm creating an pluggable database as an application container. So if you see, I use as application container clause here. Then with any PDB operation, you have to manually open it. So I did in the second box. And the third box, I I I force the I set the environment as the my application container. Here in the second screen, I'm going to install the application. So I'll say alter pluggable database application, and this is a keyword, and then I'll say app install. That'll be the name. That'll be the application name, or a tag. Then I'll say begin install, and this will be the CDB 2 CDB-2.1.0 will be the version. And then I'll run my DDLs and DMLs, which is actual process of application installation. And at the end, I'll say and install. That this is a keyword here, and the installation will be complete. So once the installation is complete on my pluggable database, then I can clone it and shape it to different places or different pluggable databases where it different container database where it will run as an application. So and this is the command where actually I created a clone, and then here I opened it. So when I have multiple clones created, and then if I want to change something on a master copy, then I can do that change, and then connect to my individual pluggable database and run this command, and that will sync those changes. So then that was installation, and then you have an option to patch and upgrade also, and that will happen in the same way. You the keywords are begin upgrade, end upgrade, and you can have your DDS and DMS within that. And and the second box talks about like how to validate it, like you connect to your actually I have a detailed explanation in the following slides, but what you can do is you can do a patching or upgrade of your master container and master pluggable database, or master pluggable application database, and then you can refresh all other clones with that, right? So, and this is how you do. You connect to your PDB app master application, and you check the application version in the second slide. Then you upgrade or patch it. So begin upgrade, and I give the new version here in the third box, and then I'll do all DDLs and emails for the upgrade, and then end upgrade. Then again I will log in and I'll check using this command, and I'll see that it will show me the new application version as 2.cdb-2.5.0. So I did patching or upgrade of my master application container, and then now I have to refresh those changes or process those changes to individual clones, and this screen will explain how you can do that. You check your application, so you connect to your clone, and then you check your application version, and then you run a sync alter pluggable database application app install this sync. And once you do a sync and check the application version, it will show you 2.5.0. So everything I talked to you about this in following in last 2-3 slides, there was a small flaw that you the scope of doing a sync operation was within a single container, which will not give you a lot. So because if you had to run all your pluggable database or application containers within a same container, then it does not make sense of using that architecture. So that the the good sense is when you good use case will be when you are using them in a different locations, different containers, and but that was not in the scope. So what they create is a new concept called proxy PDB, and what you do is you create a proxy pluggable database in a different container, right? Okay, sorry. And once you create a proxy database, so for an example, I created a proxy pluggable database out of the CDB one here, right? And just imagine this could be a application container, right? So so I have an application container here. I'll create a proxy pluggable database here, and once I create a proxy database here, then all these pluggable databases here can use it as a master copy of application container. So uh, then I can run the sync. So if my application container here, this was the source, I created a proxy here, and now within CDB2, all the pluggable databases I have, sorry, all the pluggable database I have, this will be local for them, so I can do a sync operation. So that was proxy pluggable database. And with that, I will jump into the in-memory features, which were introduced in 12.1 and 12.2. And if any questions we have, we'll take at the end. So what was in-memory feature? Traditionally, you store data in row-wise format, which is very good for uh, operations where you are retrieving the whole row or many columns, but fewer rows. And that's a typical OLTP. But in online operation, you tend, but in the warehouse environment, you tend to retrieve less columns, more rows. And if you have to retrieve 2 columns, but you're retrieving the whole row, that's not a cost-effective option of doing this. But until 12.1 IM patch, you didn't have an option to fix. With 12.1, it it uh, it gave you an option to uh, create an in-memory column store, and Oracle will make sure that it maintains the transactional consistency. So your data will be stored in database in a row format and column format both. And this was 12.1. So why use in-memory? Because you get the benefits of it. You keep anything in the memory or disk, you'll get the benefit of memory because uh, if the data is stored in memory, then it'll be faster to access, right? But with Oracle in memory option, that was not it. There were like another software based enhancement. So um, you you get a benefit of compression. So you can compress data in memory, one thing, and then um, it was the database software was aware of it. So then when to use, when not to use was also a possibility. Database knew when to use, when not to use, one thing. And only needed columns will be scanned, and then there were another features like zoom filters on the compressed data. And then you have an option to use a SIMD, like single instruction multiple data. Within 12.1, you can use aggregation using vector group by clause. With 12.2, there was and I apologize for this bad graphics. For some reason it looks like it's just expanding it further in the tool, and that's why uh, it's not clear. But uh, the last slide, you'll have my contact information, and if you can send me an email or reach out to me via Twitter, I should be able to send you these slides, and when you run in your local mode, they'll look clean. So 12.2 came with a new enhancement that you can run your in-memory column store on an active data guard side, and uh, it was again a very good game changer feature because um, you, you can run your reporting from there, and if in-memory column store is running, then you can run real analytics from your active data guard side. All you need to do is set in-memory size parameter on active data guard side, and this is not it. Then you have an option to create an in-memory column store exactly same as primary, or you can have a different in-memory column store. So you can put XYZ tables on production side, but you'll have an option to pick A, B, C tables on a standby side. So you can have entirely different in-memory column store on active data guard side. And the way you implement is you create a service and use this keyword in memory distribute for service, right? And then if you do not want to create your in-memory column store on a production side, but just on an active data guard side, you can do that. So data is in your in-memory column store, and now you have to decide what all to keep in memory column store and what all to phase out. You could use there's an implementation of heat maps for in memory, and you can use that. And the way it works is it will access the frequency of data access, and then it'll track like data add remove from in memory column store is based on the temperature and memory pressure. And what I mean to say is how much available memory you have, and what is the frequency of data access. Based on that, it will decide. And it can be user defined too, which I'll be talking about in following slides. So but if you want to use the automatic mode without further intervention from you, all you need to do is set the heat map on memory ADO enable true, and it works when you have a 90% of or more of your in-memory column storage used. If you want to change that behavior, there is another parameter, this underscore parameter. You can change the threshold, so you can keep it, you can make it 80, 70, or whatever you want. But most of the in-memory implementations, I do not see a reason why you want to change it. But if you want to, then there is an option. So this is when you want Oracle to manage it. Then if you want to manage that process, you can do it manually also. You need to set, as I said, the first thing you need to set init Aura parameter heat map on, and then now you can create your ADO policies. So for an example, I'll say like alter table Anuj ILM add policy no in memory after 10 days of no modification. So if I see that there is no change happening in that table, or after 10 days, I know that table is not going to be frequently accessed, then I can create this policy. Or I mean, I can create anything which I want, but this is just an example. No in memory after 1, 10, 20 days of creation. So if I know that there is a table which gets created, will go in memory, but there is less chances of use after 4 months. I can create that policy. If there was no access happening for 25 days, then I can safely assume, if I can safely assume that this user is not going to access this table, then I can do it no in memory, and there could be n number of combinations which you can use to create these policies. So that was if you want to control in memory column store yourself. Now, join operations Bloom filter. So um, within in memory, how joins could be enhanced. So, but to get the benefit of Bloom filters, there were certain conditions that need to be met, like join two columns, but the where clause should be on a small table. And when where clause is evaluated first, the result set will go to the second table, and the result of the first operation will transfer to the bigger table scan. So essentially, Bloom filter converted a multi-table join to a faster scan operation rather than doing all those sorting and all. But as I said, it is a requirement which is in the sorry. Let me go back. Uh, but the condition is like the where clause should be on a small table. So then you have a hash join. If you are not meeting the condition of Bloom filter, then you can do a hash join within the in memory. And in this particular example, I'm trying to do a hash join between vehicle and sales table. So here in step 1, my vehicle table is scan, and step 2, uh, I, it will create a hash table. Step 3, scan the sales table based on the decompressed matching rows. Sorry. And the step number 4 is proof the hash table using the join column. So again, it's quite faster than your regular join. But the real enhancement was 12.2 join group. Actually, if you know, like, you're going to do a join between two columns, if you know it beforehand, you can create a join group. And in the join group, uh, it will not scan the vacuum table first. It will not create a hash join, uh, and there will be no probing. So what it does is it operates on a compressed data, and database uses an array instead of building a hash table. And what I'm trying to explain here is basically, if you get into the internals, whenever it creates a table and it columns, the data is stored in symbols. So if I have to create a join group, what it will do is um, the primary key on the vehicle and primary key on the sales, wherever I want to create the join, it will use a common symbol for both of them. So there is no joining. When you do it will be when you retrieve the column on a join group, it's just a array search rather than the whole join operation which we talked in last two slides. So in memory expression, that was 12.2 feature. So here in this example, I have a query where I am calculating the data based on my table data. So I have employee ID, salary, and the commission percentage. Based on that, I'm trying to complain. Sorry. I'm trying to compile a report with weekly salary and annual compensation, which is not part of the table. So I can store these expressions pre-calculated in an in-memory column store. So there will be no runtime processing. It's already there, and you can do just a regular select statement. There are two processes involved for this: in-memory coordinator process and space management worker process. And 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 these are the views from where you can get information about this if it's actually being used. What in-memory virtual columns I have and in-memory expression uses. The difference is in-memory expression and in-memory expression. So this will give you a broader view. How you capture a expression and how you drop an expression. So if you want to drop a single expression, you'll use the first command, and if you want to drop a group of expressions, then you can use the second command. Another enhancement was in-memory. If you're running in-memory columns, creating in-memory column stores on Exadata, then you can extend it to the Flash, which is most of the Exadata. You have a huge Flash, so which is a lot bigger than the memory footprint you have on a server. So your in-memory column store can be really big if you're creating an Exadata, and it's pretty simple to implement. Um, you do a alter table cell memory, alter table no cell memory, and you can do this during the create process, also create table with the keyword cell memory, and and then you'll have all options of compression also, like here in mem compress for query low, then query high, archive low, archive high, those kind of options. The limitation is if you are using EHCC, and you can monitor the benefit with the column cell memory IM scan. With that, I'm close to done with this uh, session. If you want to read through more stuff, this is the place. Go to this link and uh, find a lot of information about 12c release 2. And the good part is now they have introduced a lot of videos, so you should be able to check them. With that, thank you very much. On the screen, you have my email address, you have my Twitter account. In case you have any questions after this webinar or maybe today, tomorrow, reach me through email or Twitter, and I'll be happy to answer any questions. With that, let me see if there is any question. Yeah. Okay. So I see there is no question. You can still have some time to ask. Um, with that, we will close today's session. But yes, reach out to me if you have any question, and I'll be happy to answer. Thank you very much.